Hello community! Today we look at Google's Agent2Agent Protocol with here the model concept protocol and with Google's new agent development kit. Let's start. So what is the situation? We have an agent and this agent can have here an MCP client architecture, and you know with MCP model context protocol we have access to our tools. A tool might be a Google search, or a weather service, the classical one. So you have an MCP client, MCP server architecture, and our model context protocol. So we can have now access to external data with this MCP client server architecture to our tools. This is it. What is the A2A protocol? It is between agents. Now, for instance, an agent waiting to retrieve real-time weather data. You have an MCP endpoint, MCP server then translate the request into whatever internal logic is required, return the real-time weather data in a structured, predictable format, JSON, effectively turning here the weather service into an accessible external data tool. Great. Now, you know, one of my last videos I showed you Google's agent development kit, and we had here, this is our agent. We had here our question answer agent, we had a description, and we had an instruction, really important, and then we just used the tool. And the tool was a predefined Google search tool by Google. So you see, easy. We don't need MCP client server architecture if we go with Google's ADK, Agent Development Kit. But if we already have a legacy architecture that you already have somewhere MCP server working, the good news is ADK is absolutely compatible with MCP client server architecture. We are compatible. Isn't this beautiful? So let's say a user asks, hey, what's the weather in Chicago? And the weather agent, we have now a weather agent. Here we have it. Our ADK agent, Gemini 2.5 or 2.0, whatever you have. You have the description. You are now the main weather agent. And we have a tool. And this is how we build agents in ADK. And the tool is here, get the weather. And then we have sub-agents. Now it gets interesting. And those sub-agents also do something. But let's stick with our examples. So the weather agent handles now what to do. And it uses here the get weather tool. Because if the question is, what is the weather in Chicago? We have really clearly, we use the tool get the weather. So we access here our weather database. This is just a mockup, never mind. And in Chicago, let's say the weather is, 23 degrees Celsius. So we return the 23 degrees Celsius here from the tool, from our get weather tool here to our agent, and we have here beautifully solved the query. So you see, it is really important, especially if we have multiple agents, to pay close attention here to the instruction and the description fields, because the LLM will rely quite heavily on this. And this agent delegation works automatically in the new Google Agent Development Kit. The default agent behavior is to allow delegation. Careful. So when processing here a user message, the LLM considers the query, the current agent description, and the description field of related agents, of parent agent or sub-agent, as defined in the hierarchy. Just showed you this. So if the LLM now determines by the linguistic content that another agent is better fitted based on the description, so a user says, for example, hi, here am I, hello, then the LLM knows the greeting agent is now the right agent to activate, and it initiates here a transfer to the greeting agent. So whenever you use ADK, the distinct descriptions are vital because the LLM uses them to route the task to the corresponding agents. Let's talk about tools. As I told you, Google Search is a beautiful tool. If you use Google, we have it predefined now. Or you use it if you have already established somewhere else, let's say crew.ai or whatever you are, LangChain, LangGraph, whatever, an MCP server for any data set. Now, you know, this database search or the Google search is a tool because it is really narrow in scope, the function. So MCP allows here for a seamless external data integration for our agents. It is something completely different if we go from agent to agent. Then we use now the new Google protocol, published 3 days ago, Agent2Agent Protocol. Now we have a different situation because now we have here a conversation AI as an agent. So we have complex multi-turn dialogues between our agent We will maintain the context, we will have a log file, and we will adjust the behavior based on the conversation flow. And this autonomy and this dynamic here, this iterative interaction between the agents is exactly what it defines an agent. A tool has not this degree of autonomy. And an agent can decide which tools to call, ask, clarify a question to the root agent, and engage here in elaborate problem solving. All those capabilities are well beyond the normal input-output behavior of a tool. And you might say, why do you focus so much on this? Because this is here the difference between an MCP and an A2A protocol. Because currently we have the discussion, hey, is an agent maybe also a tool? And the answer is not really. The idea is simply, hey, can we not use MCP for everything? Also for, let's say, an agent. If we look at an agent as a meta tool, is this possible? As it turns out, not really. So let's open up the video and let's clarify this. So when an agent's functionality is still down to a single well-bound operation with clear inputs, clear outputs, no intelligence needed, you can say, okay, we build now an MCP endpoint, that this agent can be viewed or served as a tool. So if we say this agent has no AI, artificial intelligence, if it is a rule-based something, okay, it's a tool. But whenever it goes beyond this, whenever the agent has a context, a memory, agent is able to initiate multi-turn conversation or making independent, autonomous decision, then we are talking about an agent and not anymore about a tool. And you will see we have different protocol layers. So it is not identical. An agent can be designed to serve now both rules that MCP offers. It can operate now as an MCP client to request services from external MCP servers, but it can also function here as an MCP host to expose its own internal tools or data through MCP endpoints. And in addition, it can use the A2A protocol to communicate with other agents across different ecosystems. And this is the power of A2A for me across different ecosystems. LangChain, crew.ai, whatever you have. So this inter-agent dialogue across all ecosystem is the main power of A2A, this protocol. Let's have a look at this. So here we have here our agent one, beautiful. We have MCP client, we have access to the tools, Google search or the weather service or a database or whatever you have your external data. Model context protocol connects this, beautiful. This, if you want, are non-intelligent tools. However, different agents perform maybe different tasks and they have, memory, a little LLM inside, and they have kind of intelligence, and you have here the A2A protocol. However, our agent maybe in its performance of intelligence, it maybe create now with all the data a new database. Let's call it database 13. And now our agent that served only as an MCP client now can become an MCP server. Why? Because this database 13 is now a tool. I don't want to draw it as a tool, but you can imagine this. And now we just have access and say, okay, we become now an MCP server. So any other MCP client from any other agent can now access our data of the database 13 via the model context protocol, a standardized protocol, communication protocol for the data. So if agent 3 only wants data from the database 13, you see our agent can incorporate the architecture of an MCP client, of an MCP server, and if you want that the agent collaborate on an artificial intelligence level, you can now activate the A2A protocol. This only if the agent 1 will have a multi-turn conversation with agent 3, if they have to exchange something about the strategy, about the reasoning process, about how they work together. If not, if you just want data, MCP server might be the better solution, or you go with ADK. If not, if you already have established somewhere this client server and MCP, it is compatible. Beautiful. So you see, this is the whole image. This clarifies everything about MCP and A2A protocols. Just a short reminder, MCP client role, MCP host role, beautiful. and A2A communication, agent-to-agent interaction, negotiate complex multi-step orientation. We're working cross-ecosystem, crew.ai, whatever you have. This new Google ADK is compatible. If you think only with one company, oh no, they have now more than 50 companies already before they published it. So the agent-to-agent interoperability is with their partners from Accenture to Deloitte to PricewaterhouseCoopers to Salesforce to SAP to MongoDB, Neo4j, whatever you have. They already were integrated here and they agreed here, contributing here to the Agent2Agent protocol. So if you're in the business, you know it. Short summary, Agent2Agent protocol built around here standard, HTTP for transport, JSON RPC 2.0 for message exchange and server send events SSE for real-time streaming. Key component is here the agent card. This is simply a JSON file that is attached to the agent, visible to all the other agents, that hosts here a well-known URL to advertise here the capabilities of this specific agent and the connection details. Thereby, this enables now a dynamic discovery by other agents. So it is like a flag that the agent waves around in with agent's card. Yeah? JSON file says, hey, I'm here. I have those and those capabilities. You can connect to me as an agent in this way and form, and I will perform whatever I defined here. This is nice because, the next step will be called, a network of agents and maybe an internet of agents. You can imagine what's going to happen. Structured task lifecycle, agents to initiate tasks, exchange messages, and track the progress. A2A supports streaming via SSE, push notifications, client-provided webhooks for proactive updates. Great. Let's have a look at an example. Let's say we have a virtual research assistant. This is now an agent. And we have other agent in our research lab. Now, this research assistant as an agent now can use MCP in two ways. As a client, it queries here a different MCP server connected to external scientific publication databases to retrieve the latest research papers on a given topic. It can serve as a host by providing here some analysis, but while doing this, it can also employ the Agent2Agent protocol to communicate with other agents here in the multi-agent research lab, be an agent that manages here a lab equipment to perform some experiments. So you see, you have here a beautiful variety, and the beauty is in this new Google ecosystem with A2A and the Agent Development Kit, they are compatible to MCP. So if MCP is already there in your system, in your enterprise application, no problem. Google is absolutely compatible, but offers also advanced functionalities. Summary. The agent's architecture is modular, MCP for inbound, client and outbound host tools interaction, while using A2A for cross-system dialogue with other agents, flexibility, seamless integration. A little bit more technical stuff if you want. This is for me in my internal notes here. MCP client role, JSON RPC 2.0 interface, JSON parameters that you might find. And if you have your research assistant now as an MCP client, issuing now JSON RPC calls, server returns JSON data with this hit, for example, that you have. You have also endpoints over HTTPS, and you have here MCP calls, search publication, query, whatever. You have asynchronous or streaming calls, also server-side events or chunked HTTP. Also, if you have MCP host role, MCP endpoints, call it with the proper JSON parameter and get the processed results. Beautiful. And then, of course, this lab equipment agent. If you have here an agent-to-agent communication protocol, this agent card shows all other agents in the network, hey, I'm here an agent, I'm free, I can do this, I'm available for you. This is the way you can connect to me. Note that the communication protocol is at a higher level than the MCP protocol. We are more on a task-oriented dialogue exchange here in the JSON messages. For example, we have a task request with the instruction to set up experiment with the chemicals A, B, and the temperature C. Then followed by a task reply update on the progress. And now it is interesting, because now the task message can now reference the lab equipment agent network address, and JSON might have the file task type, configure now the lab equipment, beautiful. The lab agent now responds with the status update. Experiment is loaded, standing by for the final trigger. So you have now, if you want, an agent doing the experiment and an agent just checking the latest publication, the latest data here on the databases to design here the perfect element with the perfect combination of chemical A, B, C, D at the temperature, whatever is in the literature. This bidirectional communication is real nice because imagine that the equipment agent detects that the chemical B is missing. So we have a problem. No, not at all. Because it just goes back and says, hey, agent A, or whatever, the root agent, I found out that I have a problem here. And then the research assistant, the research agent can update now the parameter and resend it in a different configuration where chemical B is not needed anymore. So you see, this is the future, if you want, of labs in the future, where you have really agent with a clear defined operational field, with a strategic field, with a planning field. They can exchange, communicate with each other, solve problems together without any human interactions. So if you have the user request, hey, run the advanced stats we developed last week, sensor data, compare the results with the relevant literature, with the latest literature, and prepare the lab equipment for an extended follow-up experiment, we will use now everything that we have. If we have to rely on MCP, no problem, because Google's now A2A ecosystem, the agent space here, is compatible with MCP. So MCP client to the external publication, MCP host for analytics, and A2A to the lab equipment agent. So the research agent sends now an A2A message here, instructing here the lab equipment agent to set up the parameters, gather the materials, and give me an update, and then just do it. So nice that Google now really designed here an agent-to-agent protocol that goes across different ecosystems. It is so great that it did not stick here to only the Google ecosystem that say, hey, we are open to every other agent system. So because we do have agent frameworks, I don't know, 20, 25, maybe up to 50 already, be open, be compatible, be open source. I think this is a brilliant way from Google, open source, open to the others. And you are the meta agent-to-agent protocol that is compatible with everybody else. So nice. If you go to a company, if you are consulting, whatever, and you have legacy systems with this, they are compatible. This is gorgeous because you don't always start fresh. So documentation also mentions by Google. I just checked it here, the sample agents using here our agent development kit, or you go with crew.ai, LangGraph, or GenKit from Google. All utilize here the A2A protocol. So beautiful, indicates that agent built with frameworks like crew.ai can indeed connect with other A2A enabled agents, Google agent, Anthropic agents. This is so nice, open source, and it goes across ecosystem, across the silos. Google also stated explicitly, I checked here the reference, that A2A is designed to complement here the model context protocol. You see already here model, LLM context protocol, and agent-to-agent here, a higher level protocol. Compatible MCP focuses here on AI models, LLM models, to external data and to external tools. And agent-to-agent focuses here on agent, Anthropic-based agent, combining now with Google-based agent. So clear where those protocols have their home. Core element, yeah. This, I will just fly over. This is now the detailed MCP architecture. We have now 3 primitives, tool, resource, and prompts. And then we go servers and events, JSON. Beautiful MCP, yeah. Resources, prompts. Same for A2A. How we integrate the system. Key functionalities, this is I found interesting, this capability discovery with the agent card. I found it so beautiful, you know. Somewhere in the network is the agent and says, hey, I'm free, I'm an agent, I can do this. You can connect to me in this way. And I have an intelligence and I have an experience and I've been fine-tuned as an AI LLM on those and those tasks. And I will report here the output in a JSON form to you. Such a nice idea. Task management now, synchronization, real-time exchange, artifacts, security for Google. The main point I would say here, You have an enterprise authentication, open API-based authorization, security, so important here, long-running task, modality agnostic communication. It also will work with video when the LLMs and the vision language model and the video systems negotiate compact representation across cross-platforms. So nice that it is open source. A2A, yep. SSE, workflow involving clients, too complicated, streaming, yeah, works everything. What's nice, I deducted for me 5 core principles here of A2A. Ne? It's being agentic first, adhering to existing standards, ensuring his security by default, so both short-term and long task, chain of thought, for example, and embracing collaboration in unstructured modalities. It is really a nice solution here. I think it is better than all the other agentic frameworks and frameworks that we have right now because cross ecosystem. Future-proofing AI strategy. Yes, I believe Google will further develop this. Yep. What we have, MCP focusing on connecting individual AI models, LLM, to external data and tools, thereby enhancing now the LLM capabilities, while A2A provides the framework for those enhanced agents to communicate and coordinate their action between the agents for more complex goals. We see clearly differentiated. Let's come to an end. What we have, what I like is this dynamic agent discovery and the dynamic tool discovery by Google, by the new Google framework. This is so great, and it is compatible to the old MCP protocol. Isn't this fantastic? Seamless integration between diverse A2A agents, beautiful, and individual LLM-powered application with external knowledge, MCP. Great, it works. So I hope this is it. This is my overview. This is because I wanted to understand, hey, how can I use Agent2Agent Protocol here with ADK, or can I use also the legacy MCP servers? How can I integrate them? What are the problems, what they are focusing on? How did Google design them? For what specific use cases? For what compatibility issues? What about security issues if I combine them? Everything is compatible. Real nice. As I told you, A2A now 3 days on the market, brand new. ADK also 3 days on the market. I have a specific video on ADK. So if you're interested, hey, why not subscribe? And I see you in my next video.